naman tagpa mainit, magpabugnaw na sad ta. So our second example for temperature problem is the freezing cold Red Horse beer. Oh, di ba? Beer below zero. So bugnaw kay ba? A bottle of Red Horse beer was served freezing cold at -4 degrees Celsius. So below zero gid siya. So after 10 minutes, its temperature is changed to 6 degrees Celsius. So nanatay initial nga T0 equal to -4 degrees Celsius. Then our new temperature, T at 10 minutes, it's 6 degrees Celsius. If the ambient temperature, Ts, is equal to 25 degrees Celsius, so 25 degrees, that is the typical temperature, no? 25 degrees Celsius. So nagawas na sila nag-inom. So what is the temperature of the beer after 10 minutes? Another 10 minutes yan pauta na. So another 10 minutes, that's 20, no? T20 yung gipangita. So before tamabot sa 20, of course we know nga ang K wala gid tay value. So let's use these. T equal to TO, which is -4, minus TS, that is 6, times E to the negative KT. KT lang sa. And then plus TS. TS is 25. TO minus TS, sorry, sayop ni siya. TO minus TS. So that should be 25. Okay, so let's simplify this. -29 e to the negative KT plus 25. This is actually our equation of temperature at any given time. So muna yung term no? At any given time. Now, let us use this to find K first because we cannot proceed with T20 without the value of K. So, find K. So, you'll use this T10 at 6 degrees Celsius. So, we have 6 degrees Celsius equal to, that is T10, no? 16 -29 e to the negative K at 10 minutes plus 25. So, 25, -25 plus 6, that is 19. No? 19, so that's ln of 19 over -29. So, positive na ni siya over -10. So, that is K. K is therefore equal to 0.04229. Okay, so we have the value of K. Ato siyang i-substitute diri. Okay, and so we will have then at T, what is T? At T equal to 20 minutes, no? 20 minutes. So let's have T equal to -29 e to the negative 0.04229 times T plus 25. Okay, so use your calculator. This will become 12.55 degrees Celsius. So compared to the ambient temperature, bugnaw pagyapon ng atong beer. After 20 minutes gikan pagkuha, bugnaw pa siya, napa siya sa 12.55 degrees Celsius. So di man ka mabalaka kay naman tay ice, no? Tangan na to siya ice. Now, you also notice nga ang ice, mahilis man siya, di ba mahilis? And then until it adapts to the ambient temperature, kay mo man jud na yang apason ang sa iyang environment. And then maingon din imong kainom ilabay ang tubig kay kahilis ng ice, no? Sayop na siya because inyo nang hunahon iniginom ninyo ang ice, mag-apas siya sa temperature sa iya mo, nag-melt siya, no? Just like the beer, mo melt siya later on because the ambient temperature is way far from its freezing temperature, no? Freezing cold na temperature gikan sa freezer. So the same with ice. So pagkalanay niya kay gaapas siya sa 25 degrees Celsius, imo tong ilabay ang tubig, mas paspas siya mahilis. Of course, kaysa katong ice, mas bugnaw man siya compare sa ambient temperature. So ang iyahang pagkalanay is inanay pod. Okay? So, munang ayaw ilabay ang tubig. Okay? May nga na ba din mo nga gilumot na ang baso. Okay? Now, we proceed with the motions and fluids with resistive forces, or shall we say, ang best example na to ani are free-falling bodies in the presence of air resistance. And then, the dE here is obtained using the Newton's second law of motion, no? Force equals mass times acceleration, no? So, here, we find the solution that describes the velocity of the object at any given time, and we can also find the initial distance traveled by the object. So, free falling, pero may baon na to ang asa na siya dapita sa air. In the case of our example with a skydiver, at example ana, we can find the altitude, asa na siya dapita at any given time, and also calculate the terminal velocity. What is terminal velocity? We will discuss in the next page. Now, isabay na to aning example are the formula that we will be using if the problem will be about free falling bodies. Now, an object with mass m is dropped from rest at a certain height. So, from rest, 0 ng rest, diba? H above the ground. So, pani si Bradick. So, si Bradick na siya gipang tagak. So, let's just focus on one object ngayong gitagak kani. Okay? And then, the air exerts a force of the object proportional to its velocity. So, muna actually ang giingon nga drag force. Now, what is a dE that describes the motion of the object? Find the velocity of the object as a function of time. And what is the terminal velocity of the object? Now, let us draw this object ng gitagak ni Bradick's. Karon, atong i-large scale kunuhay, no? So, large scale. Kadako na to. Dili lang ta magdrawing dapit kay mag-solve ra bata. Let's say this is the object ngayong gitagak. This is a apple. Tagak niya puli siya ganan kay naay ulod. Okay? From rest, you can sa ibabaw yung gitagak. Pabos, of course, pabos po itagak pataas, no? So, based on the definition, so we have this usual force on Newton's law of motion na agid ni siya, no? Ang gapakanaog, there is this mass times gravity, no? This is the force, the normal force niya. And then we have this opposing force. Unsa man yung opposing force? It says here, when the air exerts a force, mo ni siya actually drag force, or the air resistance, or the opposing force, proportional to its velocity. So we have this drag force proportional to velocity. So ang other way of expressing it, it's K times V. Pasaka. Okay, pasaka. Now, we know for the second law of motion ni Newton, the net force of a body, or the net force acting on a body, is equal to mass times acceleration. So, muna itong way, because of this law, makahimutag differential equation, ani nga scenario. Okay? So, the net force, let us have the mg, which is the force paubos. This is the normal force because ang gravity paubos man. So, this is positive. And the drag force is opposite, that is kv, equal to mass times acceleration. Karon, we know that acceleration is the time derivative of velocity. So, we can represent it as dv over dt. Okay? A equal to dv over dt. Basically, mo man jud niya atong kuan na, no? We're looking for the velocity. So, let us substitute mg kv equal to m times dv over dt. Then, let us rearrange this. Na, as you can see, this is actually a first order linear differential equation. Fold din siya, no? Ato lang ning ibalhin ang dv over dt on the leftmost part, then divide everything with m, so that the coefficient will remain 1, and voila. But also the equation, you will notice that it is separable. So in case you wanted to do folding, you can do that, but mas complex magud siya, so we can just do separable. Why do we need to do something complex nga na may mas sayon? Before that, we rearrange this. So we divide everything with m and move dv on the other side. So, ma-eliminate ni diri, ma-eliminate ni diri. And so, we have KVM. Then, we move this there. Move this also the other side. So, this becomes dV over dt equal to G minus K over M times V. Okay, so as you can see, we have to express manggod muna inani siya because we have to express V is our dependent variable. So the equation like this one, this is actually our kuan pa, wala pa na finalize nga general solution or differential equation. This is in the function of t, no? So it should be expressed in this manner. So muna siyang inani, dv over dt equal to G minus K over M times V. But first, we look at a scenario or a situation where the dv over dt is 0, meaning there is no acceleration. So at dv over dt equal to 0 means no acceleration. So when does this happen? Remember, when we drop an object, so this is the object na itong itagap. Sa sige niyang naog, this one weakens, no? Kaya panaog na siya. And this drag force becomes larger. And so, until it becomes in the, tawag nila og equilibrium. Because, apparently, there will be no acceleration kay na constant na ang iyang drag force or kV into, or kV becomes equal to mg. So, at no acceleration, we can try to equate this, or we can try to simplify this, no? Into, let dv over dt equal to 0. So, this is 0 equal to G minus K. No. Let us separate, let us have this separable first. No, before nato ni siya i-kuan. Hold on. Before this happens, ilang na to na i-reason because di man ta paingon, no? So, before this happens, na mag dv over dt 0 ta, we can eliminate km beside v, so we can separate it. So, this should become dv over dt equal to, we can have k over m as ipagawas na to siya. Then, since g don't have e coefficient, no siya tapad, still, this is actually a constant, k over m is also constant. But, we can have m over k times g minus v. Okay, so, we can just have all this in the parentheses, move dito sa dv, and we have dt, k over m ang multiplier. So, now, this is separable. No, separable na yun kaayo. This one is kind of off because wala naman naka-bracket. Okay. Now, after this, again, the nature of dv over dt equal to 0 means no acceleration. We can let this to 0. This becomes k over m times mk g minus v, or this v now becomes mg over k. Okay, this v actually is the terminal velocity. So, this terminal velocity appears when there is no acceleration. Okay, no more acceleration. So, why not use this vt to be substituted from the kaninga equation? Okay, also here, no? So, we rewrite the equation using the terminal velocity as part of the equation. This dv over dt becomes k over m, because mgk mo man siya, mg over k. This is vt minus v. O, diba? It looks simpler, looks prettier. Then we separate. So this becomes dv over vt minus v, no? Equal to k over m times dt. Ayan. Then we can integrate, no? This is now ready to integrate. this part. So when we integrate this and integrate this becomes ln of vt minus v, no? Then equal to k over m is a constant, so we as is na siya, plus t times t plus c. Okay, na-integrate naman ta. And then we raise everything to e to eliminate this ln. Then we will have now vt minus v equal to e to the kt. Where is this? Sorry. The it should be negative km. So this should be negative km. Yeah, negative km because v is positive, km becomes negative. Okay, wala pa, lilipat ta. E to the km times t plus c. Tama ba ko? Negative. Yeah, it should be. Hold on. Okay, so basta it's negative km. Balhin man gud nato ni siya. We will have vt, then v now becomes v positive, then e is negative. We have vt negative e negative km k over m times t plus c. Or this can be written as v equals vt minus c e to the negative k over m times t. Negative siya in a sense nga decreasing, no? Decreasing. So this becomes negative here. Now we need to find c, so this is our general solution. Decreasing siya in a sense nga the velocity kaning when everything here is 0, meaning walay velocity. If you notice, later na lang yan na explain. So let's find c first, knowing that the initial velocity is equal to 0 because napaman siya diri sa ibabaw, no? Wala pa man siya velocity at time equal to 0. At time equal to 0, so we can have like 0 ang v, vt minus c times time equal to 0. This becomes just 1. So obviously we have c equal to vt. So we rewrite the equation using the new value of c. That's v equal to, we have common vt and vt here. This becomes 1 minus e to the negative k over m times t. So this is our new equation. Of the velocity at any given time, or the particular solution, the particular solution. Okay, so first question, the DE. So basically naka-answer ta diri na nga part, no? Number 1 was the DE describes the motion of the object. So pwede ni siya This can be the equation, or this one is okay. And then we have the terminal velocity. This one is terminal velocity, and then we have velocity. Find the velocity of the as a function of time. So this one. Okay. Next, find the distance y it has traveled after t seconds. Now, we know that this distance is related to the velocity because v is equal to dy over dt. Diba? Kaya di man gikan ang distance y. So, when we integrate this, since v is a given value or constant, so we can try to integrate, no, to find y. So, ano na siya, no? Murag separable. So, we have dy equal to v dt, then integrate. This becomes y equal to v times rv dt. So, our v is actually the v that we have earlier, no? V equal to v times v of t 1. No, dito mag-shortcut because we have to integrate each. So, v equal to v of t minus v of t times e to the negative k over m times t. So, mama niya itong v. We just integrate this. Vt e to the negative km t dt. So, okay, na-integrate na ito sa left side. Sa dunganon sa nato siya. Like that. This vt is constant. So, you just have to integrate with the kaning naka t. No? So, we have y here equal to vt minus kaning expression vt times inverse here. Inverse of this, no? Denominator naman siya. This becomes m over k times e to the negative k over m times t plus c. So, basta sa ito equation, no? So, there is a common term. We have this vt here. So, we can vtt ni siya. Okay? Like we integrate man this term and this term. So, y is now equal to vt times t minus it's plus m over k e to the negative k over m times t plus c. Now, di pa man siya final because we're looking for the exact distance y. So, we have to find the c. Now, what initial condition can we apply? So, perhaps for y, the distance, is a sugod, the distance traveled. So, let's say we draw here our katong ganina, no? This is our initial height. This is the ground. Sige, atang lang, this is the ground na taga katong object. Then, this y actually is distance traveled. So, napa na siya diri dapit. Pag drop sa object here, napa na siya diri. This is our y. Yan pangutan na. So, pangutan na is y. What is this? No, this y here, the initial y actually is still 0. So, we can have at 0 time. Diba? Kaya wala pa man. Huwag mo niya gitagak. So, we can have this 0 equal to v of t times 0 plus this one is 0. This becomes m over k. No? Plus c. Meaning, our c is equal to negative vt m over k. Tama? Okay. So, rewrite the equation. Taas kaya itong y. Y is equal to v of t, which is common to all terms. We have t plus m over k times e to the negative k over m times t minus m over k. So, this is our equation for finding the distance. So, di man ta makataw value because there's no value given. So, this is just a formula. Now, there's another question. What is the height at any given time? So, basically, it's looking for the height here. Muna siya. Height at any given time. So, we're looking for the height, which is equal to h is actually ho minus y. So, muna siya tong. These are what we were able to derive based on the scenario. So, this one is very useful. Okay? In case you're looking for the distance, you can also derive. If you forget the formula, you can derive. No? Okay? Now, we go to directly to the example. A body falls from rest against a resistance that is proportional to the speed of any distance. First, we find the terminal speed of the body at 128 feet per second. So, find its speed after 2 seconds. So, if the object is dropped at height 150 feet, what is the elevation from the ground after 2 seconds? So, asa na siya napit? So, when will the object hit the ground? So, there are different questions, no? So, let's try to one first. So, the terminal speed or terminal velocity. So, we have to, it's kind of different. Ngayon natin siya terminal velocity is 128 feet per second. And then, at t equal to 2, after 2 seconds. So, with our formula, we can have the velocity because naman ni silang duha, no? But we need to find k first. So, we don't have k, and remember, our vt is equal to mg over k. Remember, we derived that. So, our mg, the mass is what? So, wala man tayo mass. What do we do? So, we can just equate, no? Wala man tayo mass. We can have like k over m. So, let's try this, no? We rearrange this equation. Okay. Remember, our exponent here, kani siyang vt, 1 minus e to the negative k over m times t. So, this is what's the trickier part here. So, kabalo man ta nga vt is equal to mgk. But we don't have the mass. How do we do that? But we have gravity. We don't have k, but we have vt. Sige. Now, we will use the g, which is 32.2 feet per second squared. Since nakakuan mo ni siya, English mo ni siya iyang units, no? So, we can try this actually. We have exchange ni sila. We have k equal to g mg over vt. Then put here m. This is k over m equal to g over vt. Diba we have vt and we have g? So what is g? 32.2. Then we have vt, which is 128. So our k over m equal to maybe you can just later na lang, you just have the formula or the kuan as k over m lang sa. So our k over m is equal to g over vt. So later na lang na siya when we have the final value. So we can let this one here. Oh, diri. Okay? Change color to highlight. Can have the highlight here. This one, kani siya. Right? Now, so proceed na. We have this k over m times t, which is 2 seconds. And then we have vt at 128. So, we can proceed with v. Now, this v now is equal to 128 times 1 minus e to the negative g over vt times t. which is 2. Diba? So, when we calculate this, so this will be the velocity after 2 seconds. 50.36 feet per second. That is after 2 seconds, the velocity. So, this is the first question on answer na nato. Now, it says here if the object is trapped at a height 150. So, mag-drawing sa ta. We have this object na tagak pid siya, no, natagak at height 150. So, mo ni atong overall height no 150 feet from ground to up to ground. Gitagak man siya, so we have this initial height, we have this y here kung asa na ang object, and then kani may unknown, asa na siya dapita sa air. Okay, at what time did it drop or hit the ground? So first we need to find h, no, actually ang h na to is 150, but we need to find the y, no, sa man ang y. So muna yung giingon nga what is the elevation from the ground after 2 seconds. So we have 2 seconds, so we can use the equation that we found for y earlier. Grabe kataas, no? We're looking for y. So this is actually v times t equal to t plus m over k times e to the negative k over m times t minus m k. Diba? So, let's substitute 128 times 2 seconds plus that is actually 28. Let's just say this is just 32, no? So 128 over 32, that is actually 4 e to the negative m over k, k over m, this is negative 1/4, no? 32 over 128 times t, times 2 seconds minus m over k, which is equal to 4. Okay, so y now is actually equal to 54.54 feet. So solve this one, you will find 54.54 feet. So this is our y, no? Napa atong object diri at 2 seconds. Now, ang pangutana niya is, this is the elevation after 2 seconds. Now, when will the object hit the ground? So, when man kanusa. So, by the way, let's find h first. Gusto ta makabalo kung asa na siya dapit from the ground. So, h equal to 150 minus 54.54, that is 95.46 feet. Kung muhangad ka, napa siya dito sa 95 degrees, 95.46 feet. Now, so at y equal to 150, meaning naabot na siya sa ground, no? Y equal to 150. Man ang time. What time is it? Sorry, what time is it? Okay, so using this same equation na nakay y nga 150, no? Our VT is 128 times t, mo na itong gipangita, t plus 4 e to the negative 140 minus 4. Okay, and so we try this, simplify that, this becomes 150 over 128 plus 4, so on and so forth. So kabalo naman mo solve ani, t is actually equal to 3.507 seconds. So this is the total time of the object in the air actually, gikan sa pagtaga kay 150 baya. So, muna ito ang ipangita here. Okay, last example is a 2 kilogram ball is dropped from breast in a fluid. Fluid can be the air or liquid. Maghapon na siya, in which the resistance force is 0.8 v, where v is the instantaneous velocity in meter per second. What is the speed of the ball after 4 seconds? Now, and then siya, how far has it traveled? Wala ko nasulat, no? So, let's jot down first. The mass is actually 2 kilogram. Then we have this drag force. Actually, this resistance force is the drag force, Fd, equal to 0.8 v. Meaning, okay, Fd is actually equal to kv. Our k is equal to 0.8. Okay? So, dito makalimutan ng Fd equal to kv. Now, what is v at 4 seconds? And what is y? Yung mga na how far has it traveled? Wala na din ako nasulat how far. How far has it traveled? Ana. Now, first and foremost, we have k already na natay mass. Then, we have time, which is drag force k. So I think we can have vt. So let's try. Now in this equation, v equal to v of t times 1 minus e to the negative k over m times t. Okay, and so we have, and also remember this vt is actually mg over k. So this is equal to, ang atong vt is 2 kilograms, substitute na to ani, times, this is in metric, so unaan siya sa 9.8 meter per second squared, and then k is 0.8. So our terminal velocity is actually 24.5 meter per second. So nanatay vt. Now from this vt, we can use na this equation at 4 seconds. So v at 4 seconds is equal to vt, that is 24.5 times 1 minus e to the negative k over m, that's 0.8 over m, which is 2 times 4, the time, 4 seconds. So this is 2, that's 1.6. And so our v after 4 seconds is equal to 19.55 meters per second. So this is basically pangitaan ni speed after 4 seconds. Now, how far has it traveled? So our y, again, pwede ito actually mo gamit inani. Integral, very integral. Y is equal to v dt, where our v, after 4 seconds man, we can have this, no? We have vt 24.5 times 1 to the e 1 minus e to the negative 0.4 t. So simply, we're substituting t after integrating with 0 and 4. And then you will actually come up with a y which is equal to 49.12, or approximately 49 meters. Yan. Yes, ayun ra. So actually the answer is just rounding with what we derived ng mga equations. Okay? Now, we also have a practice. So, kamo ni mag-solve ani. This is what I mentioned earlier ng skydiver. So, a 165 skydiver jumps off from a plane at a height of 10,000 feet. So, niambak siya. Magkuhan siya parachute ba? Then, in the first 30 seconds, wala pa na gi-release ang yung parachute. Napa siya sa drag force that is like 2v. After which, the parachute is released to increase the drag force. Now, if this time, the drag force is proportional to the square of the velocity, so nausab siya. From this case until here, we can say that Fd is equal to 2v, no? But, pag abot niya diri, the drag force is proportional to the square of the velocity. Nisaka. So, there's another equation, no? Find an expression of the velocity at any time t after the initial. So, nangita siya atong v nimo after the initial 30 seconds, meaning katong nag-release na ka sa parachute. Okay, assuming the same value of k. Same k is, I think, this should be 2. Naman diri. What is the skydiver's altitude? 2 minutes. So, nakay time. After he jumped off the plane. Asa na siya dapit after 2 minutes. Okay, pila na iyang altitude. Yan. So, kamo na bahala mo sa bana. Okay?